Hey y'all, how's it going? Let's learn about subtracting decimals. So yesterday we took a look at adding decimals because this week we are learning to add and subtract positive rational numbers or decimals fluently. At the end of this week you should be able to add and subtract decimal values using models and the standard algorithm. And you should also be able to estimate the addition and subtraction of decimals. So let's get started with subtracting decimals. Yesterday we worked on adding decimals. Remember, with adding decimals, um, follow the steps, right? Step 1, stack your decimal points and place values. Step 2, add a face to save a place. Place those emoji zeros where there's blanks to make it easier to look at. Step 3, ignore the decimal point and add like normal. So put a invisibility cloak on that decimal point or those decimal points and then just add like their whole numbers. And then finally, step 4, take that invisibility cloak off the decimal points and drop that decimal point like it's hot to the bottom in the answer. All right, so let's take a look at today's lesson. Here we go. So, study the image. It looks like they're trying to say that we are measuring from this purple line to this purple line. This looks to be a little bit over 1.5, and this looks to be a little bit over 5, and then the unit is millimeters. So something like 16, 17 millimeters and 52 millimeters maybe. Let's find out. Okay, so they might want us to subtract a difference. All right, so they're trying to say that we need to find out what the difference is. So if we had an item that was, let's say, 4 and 56 hundredths inches, centimeters, millimeters, and then we had another one that was only 2 and 23 hundredths, and we wanted to find the difference, we would subtract them. All right, so just like before, we're going to look at base 10 blocks to represent decimals. Remember, this is your whole right here. So that is a whole, that is a tenth, and this is a hundredth. All right, so one whole, 1/10, 1/100th. So as you can see over here on the picture, to represent 4 and 56 hundredths, you have 4 wholes, 5/10ths, and 6 hundredths. And then over here, if we built the 2 and 23 hundredths, that would be an addition problem. All right, so we're not going to build. In fact, what they do is they take away. So in real life, to take away, you would just take it away. Bye, right? It's gone. See you later. Boing! They're gone. But in a drawing, you can't just erase the test or erase this picture. You can't erase your screen, right? That doesn't work. So usually what they're going to do is cross out pieces. So they would cross out 2 wholes, 2/10ths, and 3/100ths. Cross out 2 wholes, 2/10ths, 3/100ths, right? So let's see what that looks like whenever we draw a picture of it. So once again, there's your 4 and 56 hundredths, and then you took away 2 and 2/10ths and 3/100ths. All right, so they took away 2 wholes, 2/10ths, and 3/100ths. That's why they crossed them out. You can see they crossed out 2 wholes, 2/10ths, and 3/100ths. So let's find out, how much do they have left over. They have 1 whole, they have 2 wholes, they have 1, 2, 3/10ths, and they have 1, 2, 3/100ths. So it looks like our answer would be 2 and 33 hundredths. So the difference between 4 and 56 hundredths and 2 and 23 hundredths would be 2 and 33 hundredths. 2 wholes, 3/10ths, 3/100ths, or 2 and 33 hundredths. If we did that as the algorithm, we would set that problem up the same way we set up the addition problems yesterday. So come back for the next video and let's take a look at how we would do that with the algorithm. I will see you then.